All right, so today we're gonna finish this worksheet. We're gonna do 11 through 13. 11 through 13 is going to be similar to the one we worked yesterday, number 10. So we're not being asked to find the limiting reactant. We're asked to find the mass of a product, but in order to do that, you have to find the limiting reactant. So we'll start with the balanced chemical reaction. It's telling us that SO2 is produced, so we're taking S8 and we are reacting it with O2. And they're telling us we're going to produce SO2. So you've got to balance this. So 8, I need to get 8 here to get 8 sulfurs, and then that's 16, put an 8 here. We'll make our table. Remember, you have 0 of your product before the reaction occurs. You can fill in the change, minus x, minus 8x, plus 8x. And then we need to convert the grams they give us. So they're giving us 31.5 grams of S8. And we can convert that grams to moles. Let's find the mass of S8. Sulfur's 32.06. We'll multiply that by 8 to get 256.48. And so from there we can find the number of moles. Here we're getting 0.123. And here 8.65 divided by 32, we're getting 0.270. So we can plug those numbers in, 0.123, 0.270. And you can look at which one's gonna go to 0. So you notice that there's similar amounts, but this is being reacted 8 times faster than this. So I have about twice as much O2, but because it's disappearing, or not disappearing, but because it's reacting 8 times faster, I'm gonna go ahead and say that one is 0. I can now solve for x and say 0.270 minus 8x equals 0. And I can get that x is 0.03375. So let's plug that back in here to make sure we get a positive number. And we do, we get 0.08925. That means we picked the right one to go to 0, so let's plug this in over here. And we should end up right here with 0.27 moles. And the question said, well, how many grams? So we'll just take 0.27 moles of SO2 and 1 mole. Let's see. We'll get 64 grams, and we can solve. And we can know that we had 17 we'll say 30 grams of SO2. So again, same process that we've been following, except now we're finding the moles here, and then we're taking those moles and converting them to grams. Similar process will follow for number 12. Number 12, when we look at the reaction that they give us.
So when looking at this formula,
when we're looking at the reaction here that they give us, we're looking at SO2 is going to react with O2, and we're going to be producing SO3. And so we need to balance this here. So we have 2 and 2, that's 4. And so we look over here. So if we want to put a 2 here, that gives 2 sulfur, 2 sulfur. That gives us 6, and 2 times 2 is 4, plus 2 is 6. So again, always make sure you balance your chemical reactions before you start. We have 0 of our product before. Because we put the balance coefficients, we can now fill in the change, and then we can take the numbers that were given in the problem. 12.4 grams of SO2 and 3.45 grams of O2. We can convert those to moles. 0.194 and 0.108. And so I can plug those back in up here. And so for SO2, 0.194 and 0.108. They're similar. This is being reacted twice as fast, so let's say that goes to 0. 0.194 minus 2x equals 0. Got 0.097, and we can plug that in. We do get a positive number, so that means we picked the correct limiting reactant. And so let's go ahead and plug in our x here. We get 0.194 moles. But remember, we got to convert 0.194 moles of SO3 we can find the grams, and getting 80.06, ending up with 15.53 grams of SO3. So that's 11 and 12. And finally, we'll go to number 13. Again, number 13 is we're gonna solve in a similar fashion. Start with our balanced chemical reaction. We're reacting SO3 with H2O, and that is producing H2SO4. Now notice I wrote H2O like this. I didn't write it as HOH because over here I don't have an OH. I have H's and I have O's, but I don't have an OH, so now we're just gonna count the number of H's, the number of O's. So sulfur is 1, that's good. Hydrogen's 2, that's good. Oxygen's 3 plus 1 is 4, oxygen's 4, and so what looked to maybe be a little confusing is not, because it's already balanced for you. Start with 0 of your product before the reaction has occurred. Go ahead and fill in your change. We can take the numbers they give us in the question, we can convert those. So we're given 6.58 grams of SO3. Take that 80.06 grams that we had from the previous problem and use that to convert to moles. And then we are given 1.64 grams of H2O. So we can convert to moles. 0.0822 and 0.0911. Go ahead and plug those numbers in up here. 0.0822, 0.0911. They're being reacted by the same rate, just x, and so this is the smaller number. That's gonna run out first because I have less of it. 0.0822 minus x equals 0. X is 0.0822. We can plug that in. Hopefully that's a positive number. I'm getting 0.0089, and so we can plug in our x here, 0.0822, and we get 0.0822 moles. We can take those moles and we can convert from moles to grams. I got 98.06 grams, and I got 8.06 grams of H2SO4.